Yo, yo, yo! Yo, what's up, guys? Hope everybody's doing well. Thanks for joining for the video about ordering real numbers. So let's get it. So what we're going to do is we are going to order numbers that are written in a bunch of different, they're all going to look like they're in different forms, and we're going to put them in order from least to greatest. And we're going to compare them. So the best way to do this is to make them all look the same. So we're going to convert everything to decimals. So here's what I mean by this. You're going to have terms that might look like this. Square root of 3 plus 5, or 3 plus the square root of 5. And I want to say which side is greater, the left or the right. Okay, so what we do is we're going to approximate to our best ability, pretty much. So because with the square root of 3, we don't know exactly what the square root of 3 is. Okay, we also don't know exactly what the square root of 5 is. So what I have to do is I have to approximate the square root of 3, and I have to approximate the square root of 5, and then I can add it and then figure out which side is greater or less than. So square root of 3 is in between. And what I'm going to do is I'm going to convert these all to decimals. And then, yeah, that way when I approximate, I can convert to decimal, I can do the addition, and then we can compare. So, square root of 3 I know is in between 1 and 4. It is definitely closer to 2 than it is to 1. It's 2 away, 1 away. Okay, it's 2/3 of the way over. So, I would say it is roughly 1 2/3. But 1 2/3 is 1.6 repeating, so we can just round that up to 1.7. So that was a quick approximation. If you do not know how I did that, please go watch 14.1 part 2, because we go over that in a lot more detail. So let's say square root of 3 is right about 1.7. 1.7 plus 5, that's going to give me 6.7. Now I can easily compare that to the right-hand side once I figure out what the square root of 5 is. Well, square root of 5 is in between 2 and 3. But it's really close to 2. It's only 1 away. And it is 4 away. So that'd be 1/5. So that'd be 2.2. So if square root of 5 is 2.2, roughly, 3 plus 2.2 is 5.2. This side is clearly bigger. Now, with approximations, you might say, well, how do we know if we're exact? How do we know by approximating? Our approximations should be close enough to where they're within 1 or 2/10 of each other. These are within 1.5 of each other. This is 1.5 greater than this side. So we're for sure good. 100%. Okay. So you also might have to order from least to greatest on a number line. And you might have multiple. So I have a fraction, I have an imperfect square, and then I have pi plus 1. So I am ordering all three of these values from least to greatest on a number line. So let me put this in there too. So what I want to do is I want to make them all look like decimals, and then I'm going to place them on the number line. So pi plus 1 right away, 3.14 plus 1. This is the same thing as 4.14. 4.5 is, well, we know that's 4.5. Okay. So I have two of my values. And now I got to figure out what square root of 22 is. So for square root of 22, again, that's when you just go off to the side and we do our approximations. We know it's between 16 and 25, which means it's going to be 4 point something. How far away are we? We're 6 away. And let's see, there's a total of 9. So that'd be 6 over 9, which is 2/3, which is 6 repeating. So we're going to say 4.7 is our approximation. So there we go. So I have three values, 4.14, 4.5, and 4.7. So I'm going to order these from least to greatest. So on a number line. But on the number line, I'm not going to go like, I don't want to start with the middle at 0, then 1, 2, 3, 4, 5. Because if I did this, everything's going to be in between these two, and they're going to be really, really, really close together. So we get to zoom in on the number line, which is okay. So we're just going to take a chunk of it. We're going to zoom in, and I'm going to start here is going to be, let's just call this 4.1, 0.2, and we can count by tenths, and that's okay. 0.3, 0.4, this will be 4.5. I'll spread it out a little bit. 4.7, 4.9. Okay, so I skipped by every other one just to make it look a little bit more friendly. And now I go place this on a number line. Big thing about placing these numbers on a number line is use the original value. Square root of 22 is not equal to 4.7. So I'm trying to place the square root of 22 on a number line. So that's where I'm going to place, and I'm going to write it down as square root of 22. I'm writing the original values. These are approximations here. These are not the exact values. I want to write the exacts and their approximate area on a number line. So this would be pi plus 1. And then 4.5. There's 4.5. So now I place them on the number line with their original values. I converted them to decimals and I approximated just to know where they go on the number line, but I'm still using the original value that we were comparing. Okay. So I have a couple more where I need to compare three numbers and place them on a number line. I will do number 5, and then I want you guys to try number 6. So square root of 3, square root of 5. The nice part is I've already done square root of 3 and square root of 5, so I already know square root of 3 is 1.7. Square root of 5 is 2.2. I'm not going to go over that again. Square root of 3 is 1.7. Square root of 5 is 2.2, and then I had 2.5. So I already have my three values to order from least to greatest. So I'm going to rewrite them in order from least to greatest because it's asking us to do that right here. And I'm going to use my original values. So we know the least because 1.7 is less than 2.2. So the least is square root of 3, then square root of 5, then 2.5. Those are my numbers in order from least to greatest. Square root of 3, 1.7 would go right about here. And sometimes it's nice just to draw a line to that spot where we think it would be and then go work above it. So there's a square root of 3. 0.2 right about here, square root of 5, and right there is 2.5. And I placed them all on the number line. Okay, try number 6. Pause the video and then hit play afterwards so you can watch and see if you did it right, and then you can make any fixes that you need to. Okay, so I got pi squared, I've got 10, I've got square root of 75. So 10 right away, I'm just going to place 10 on the number line. Now, that one's pretty easy because it's right here. Now, pi squared, I'm going to work off to the side here. Pi squared, this, we know pi is 3.14, but it's 3.14 times itself. So this is where you're actually going to have to do some multiplication over here and multiply pi by itself. Now, I'm just going to use a calculator real quick because you guys don't need to see me multiply 3.14 by itself. But I'm going to get 9 point on the calculator. It is 9.8596. So that's what pi squared is equivalent to, is 9.8596. So that's going to be right here. And I should actually be a little bit closer. I just missed with my pen. But I should be a little bit closer to the 10 because this is definitely closer to 10 than it is here. So that would be pi squared. And then now square root of 75. I need to approximate. I know it's in between 64 and 81, which means it's going to be 8 point something. Let's see how far away. We're 11 out of 17. So I would actually do 11 divided by 17. But here's the cool part is 1. I know that's going to be closer to 9. This is an approximation. So right now, I've already have enough information to solve to answer this question. So it's going to be 8 point something greater than 5. Okay, I could do 11 divided by 17 to figure out. I'm just going to estimate 8.7 because that is roughly right about here for square root of 75. And I'm able to now order these numbers from least to greatest. The least is square root of 75. The second number is pi squared. And then 10 is the largest number. Now, if these were negatives, if I made all of these negative, then the order would be switched. The least would then be negative 10. The second least would then be pi squared. And then the third least would be square root of 75. Okay. Now, Approximate square roots. Things to remember. We want to approximate the square roots before comparing values. So we also want to remember to always compare everything as decimals. Even fractions, let's all convert everything to decimals. Okay, it's easier, it's nice and easy to compare. You have 2 independent practice problems. I want you guys to complete those. We'll check them in class. Thanks for watching, guys. And if you have any questions, do not hesitate to ask. Enjoy the rest of your day. Good day is out.